Joining us today, we are going to chat about connectivity in airplanes, and in particular, Wi-Fi. It's a big buzzword. It's kind of the latest and greatest and newest technology that we have in airplanes, and it's kind of a big must-have on the customer list of demand here. So I've had the pleasure today. We have Jim Zanino here of Gogo. Gogo is a very large provider of internet services. We have James Hardie next to Jim from Rockwell, Holland, also a large provider of data services. And then we have Arno Vanderkraan here, if I pronounced that correctly, for Inmarsat. Inmarsat owns the satellites and provides the data to the other gentleman here. So this was an interesting panel for me. I am a bit of a technophobe. I don't know too much about technology. I begrudgingly was pulled into the smartphone era about a year and a half ago. So me doing a Wi-Fi panel was informative. Then I realized I'm probably not alone in this room, and most people here probably have no idea, as I did not, how these systems work. So I'm going to ask these good gentlemen here who will know how that works just to give a general overview as to what the difference is between a satellite-owning company and a company that provides Wi-Fi is and how they all work together. So Arno, I'm going to start with you. So what does a satellite company do? So,
well, it's a good question. How long do we have?
As short as possible.
No, keep it simple. It's so us folks in the satellite industry, for us it's all staple diet. We understand how it works, but it is rocket science. It can go a bit technical. So I'll keep it simple, and I'll try to make the analogy how I actually made it understandable to my grandma. Is that a satellite company is just like a mobile phone company. We provide the connectivity, but rather than base stations or towers, we use satellites that actually carry the connectivity. We also have, let's say you use another analogy, AT&T, for instance, BT, they own and operate the the base stations, the ground infrastructure. And all they do is they provide the connectivity to your office, to your home, or in this case, to your aircraft. Not a very cheap thing to do. It's like, all the mobile phone companies, there's not a lot of companies out there. There's only a handful that could actually do that. But in essence, that is exactly what we do. So we make sure that from the office in the sky to the office back in, let's say, London in the US, an email gets sent, and if we just follow the path, it goes from the computer to the router, that's the onboard equipment, goes to the satellite, goes down to the ground earth station, goes to the actual office via the land infrastructure that we own and operate as well, and that is, in essence, the way a satellite system works.
So to boil it down for people like me here, you provide the way to get from the airplane to the ground, is that right?
Yeah, vice versa. Yep.
Okay, so James and Jim then, what happens once that signal from the sky hits the airplane? I assume that's your guys' territory, is that right?
Okay, so what we will do as a service provider is we look after the customer who's actually operating the aircraft. We're going to make sure that they've got the right tools that they can use the aircraft, manage the systems on board, understand what it's being used for, how much is being spent on it, and then we're also a first point of call for any troubleshooting. We can look into the network systems in different ways to establish whether or not it's a network issue. It might be a network issue on our end, it might be something on Inmarsat or Viasat's end. We would work with that satellite service provider to resolve any other network issues before we kind of get back to the customer and maybe say, hey, it might be a box issue, in which case if it's a Rockwell Collins box then it's still on us as well, so that's kind of what we do.
So Jim, what do you guys do then?
Yeah, so we provide the hardware that's usually in the airplane, so the actual routers, the satellite dishes, the antennas on the bottom, it's an air-to-ground network. At the same time, we're also a network provider, so in the United States we have the air-to-ground network that Gogo's been put up in like 2008 timeframe, and that we maintain that network, we upgrade that network, we sell the services on that network, as well as on the 2KU side for the airlines, we manage that whole network as well. So we do both the hardware side and the network side on the Gogo side.
So when it comes to satellite then, so Arno sends data packages to the airplane and your technology converts data bits into Wi-Fi, is that right?
Yep.
Pretty much? Okay, good enough. We'll go with that one. So Arno, I know of Iridium, I know of Inmarsat. How many other satellite companies are there doing what you guys do?
Well, there's quite a few, and it just depends on what type of offering they give. So you have connectivity providing satellite companies. So Inmarsat is a typical connectivity provider. We don't dabble in content, but then you also have content providers, Intelsat, Eutelsat, that are mainly used for transportation of content. But Inmarsat, amongst a handful of Inmarsat, Iridium, Viasat, and there's more to come. But it depends on what type of connectivity and content you want. But yeah, there's not a lot.
But
It's rather expensive.
But surprisingly competitive, given that it's billions of dollars.
Oh yeah,
going
and
up there.
we haven't even begun yet. So
Okay. So a big question we always get is how fast is it? And I think one of the greatest naming systems of internet is Swift broadband, which for anybody who's used Swift broadband will know it is not actually broadband. So how fast is it? Give us some good examples here, and not just the published rates, because I get published rates from what I buy at home, and it's nowhere near what I actually see. So, what do we have? We have, broadband systems, we have ATG systems, we have KU and KA. How fast are all of these things? And again, to dumb it down, how fast does it need to be to stream a movie? So.
I'll go for that one. No, because it's interesting. So you touched upon Swift broadband. So if we go back a little bit further, so the Inmarsat A, which was pretty revolutionary when it comes to the maritime industry, that was phenomenal. It was a satellite dish the size of a grown man, giving you a whopping speed of 9.6, and you can make a phone call in the middle of the ocean. It's pretty impressive, right? But if you now go fast forward into the future, and then of course we're focusing on aviation here. So we had the classic aero services, telex, voice calls, all pretty revolutionary. Swift 64, now that was absolutely phenomenal because it gives you 64 kilobits per second, thank you very much. That was quite something, you can even bond them. So, and then of course that, especially when it comes to Satcom Direct, that's where they started really gaining traction into the market, and then others shortly follow, Eric Direct, Satcom One, etc. So from an aviation point of view, that was more or less the, not from a safety, but from an actual connectivity, it was the dawn of the new business aviation aircraft as we know it today for connectivity. So fantastic, Swift 64, then Swift broadband. Mind you, it was broadband at that time. But if you're looking at 432 kilobits per second, if you're lucky, it's not really broadband, is it? But it felt like it. And of course, you have deep pockets, you can bond channels, you can go streaming. And it actually, for a couple of guys in the back, in a typical BizJet, it did the trick for emails, phone conversation. And if you bonded and you were in a particularly empty beam, you could potentially do video conferencing not too well. Now, if you now look back to that, it's almost cute, because it's not broadband, it is a good start. Global Express, which is the fifth generation satellites, that goes up to 50 megabits per second. That's capable from the satellite. That is that's becoming a broadband connectivity. But it always increases, it always expands. So modem advances will make the signal go stronger, faster, and quicker, et cetera, et cetera. So what we think is broadband now, 50 megabits a second per spot beam, can go to a couple of hundred, to 500, 600, 700 megabits a second in the future. So define broadband.
Fair enough.
Okay, so on a business jet, to get it down out of the headline rates, the maximum speed you can get on the Inmarsat network is 15 megabits per second. Correct?
At the moment, yeah.
Yeah. And that's largely limited by the size of the antenna on the aircraft. So most of them are only going to have a tail-mounted antenna. It's a little bit smaller. So that's getting information onto the aircraft. Getting information off the aircraft using that same antenna to transmit, you're going to have, it's another reduction in speed. But how much, you're not going to be generating content so much on the aircraft to send off, except maybe emails, presentations, whatever. Maybe a video conferencing call, that would, so it's got adequate to be able to conduct those kind of functions. You're then looking at, so if you want to stream, well, if everyone wants to stream, nobody gets to stream. You're going to have a pretty bad experience then. I think then you want to start thinking about other aspects of, managing your content on board the aircraft. So there's various cabin management systems that will store other information. You can draw information onto the aircraft before you take off, just like you do. Maybe you load a movie onto your iPad before you go.
But for me, if I want to go onto Netflix, how much bandwidth do I need to stream a Netflix movie?
Okay, it depends on the definition, but you're looking at about 700 kilobits per second, and you'll be able to stream a movie, DVD quality.
That's slower than I thought. Okay. Now, Jim, Gogo does airline systems as well, and you guys have a new product out. I mean, so is that going to tell us a little bit about how fast that is, and then tell us, is that going to make its way down to private aviation? So.
Yeah, so we launched the 2KU product about 4 years ago, and it's really geared for the airline market and probably BBJs and ACJs. It's basically two large antennas. So what James was mentioning about that one tail mount antenna is sharing the data back and forth. So what we ended up doing was one antenna is for receiving, one antenna is for basically setting things back up. That system is getting demonstrated speeds of 100 megabits per second on those airlines because you're feeding a lot of people on that airline. And you're talking a couple hundred passengers possibly on Wi-Fi. When the system first came out, we were getting between 25 to 50, and what Arno alluded to is we changed the modems and the routers and improved the hardware in that one portion of it, and that pushed us up to 100 over time. So as these systems go over time, as new hardware comes in, you're not replacing the whole system anymore, you're replacing one portion of it, which actually saves you a lot of cost going forward. So now we're taking that system at NBAA this year. We launched what we call KU. So instead of the two KUs, because it has two antennas, the KU, similar to the KA, is going to have one single tail mounted antenna on it. We're still going to get 25 megabits per second on that system because of that modem technology that we're taking from the airlines and using that. So it's just the higher speeds that you're seeing that we're demonstrating right now in our test aircraft. That's going to go along with some lower cost plans, and I'm sure we'll get questions about that later.
So you will do, yes. So the antenna that you use on that K system, how big is that going to be? So I mean, can I put this on my Citation Mustang?
No. So it's still tail mounted, so you're looking at 11.5-inch dish, so the same size as most of your tail mounted antennas.
So this is really applicable really then only for Challengers up through Globals and Gulfstreams, is that correct?
Correct.
Okay. So I'm sure everybody in the room here has a certain beef here with how much internet costs to use, but I guess it begs the next question, how much does it actually cost to use? I think everybody here has horror stories of $50,000 one-way bills. So how much does it cost per provider here? Because I mean, clearly there's a lot of different systems that can be used. And just to make it something that even I can relate to, how much is it going to cost me to open the BBC homepage, for example? So.
I guess the way you have to take a look at managing your content. So an average website study in 2016 says about 2.8 megabytes of data to download a website. So if you're paying $8 a megabyte for data, that website just costs you $24 roughly to download that one website. So the cost, as if you buy the megabyte plans, there's a lot of plans that we offer, Satcom Direct offers, our competitors offer, where you buy it in bulk for a month. Like you buy, 10 gigabytes worth of data and you pay so much money for it, so it gets your cost down. So there's a lot of different plans to do that. The key to keeping your costs down is managing your data. Do not try to stream a movie from an airplane, because like you were saying, it's going to be a lot of data. You're going to be streaming probably, by the time you're done, close to a gigabyte worth of data, streaming a movie to your airplane. Plan ahead of time. Get the movies either on the server through cabin management systems, load them on your iPads ahead of time. The other biggest driver of data, your cell phone. How many of you actually turn off automatic updates on your cell phone for all your apps? Anytime you're out, depending on how your phone's set up, as soon as it sees Wi-Fi, it'll start updating apps automatically. That's the default setting from Apple and Samsung. You have to go and manually turn that off so it doesn't do that. So that's another way to save a lot of data. So things like that you can do to save your costs quite a bit.
We can also add in some applications like content filtering. So we'll disable at the customer request certain websites or updates from Apple and Android, whatever, automatic. The funny thing actually about that is we did a little bit of a study a couple of years ago and looking at a few customers, and when content filtering got turned on, data usage actually went up. And I think that was to do with confidence. They were then not getting onto the aircraft so fearful that it was going to be misused or inadvertently used to some terrible, like, I didn't do it. But it was actually going to be used for what they wanted to use it for. And that's where it's valuable. If you need to make that call or you need to get that information, then it's valuable. You want it at that point. And that's why when the internet goes down on these aircraft, we're getting the phones start ringing. What's wrong with it? This is, it's not a minimum equipment list. The aircraft can still go flying, can technically still do its primary mission, but it is. They'll want another aircraft, some of them.
So here's another question then. So we've seen that there's more than one satellite owning company, and there's definitely more than one provision of Wi-Fi services. Have you seen competition making it cheaper now, or has just the number of competitors proliferated at the same price?
Well, I think there was, the more you use, you can get lower price per megabyte, or for the bandwidth, there's a certain amount, there's a lot of competition going on there. But there's also, it's a fairly scarce resource, and, as more and more people use it, that's going to sort of have an impact as well. And people use it more and more. So that's another part. We can certainly do deals on volume discounts and stuff like that. Those are all already there. So if you just want it on and available for use, well, the satellite's still got to sit there, and it can only be used now. It can't be used in the past or in the future until you get there.
So it begs the next question then. If everyone's providing internet, which again, I'm a layman here, so internet to me is internet, whether I use it through Gogo, I use it through Universal or Satcom Direct. As far as I can tell, I can still log on, check my email. There's more competitors now, and the price is pretty much the same on some of these. What's the difference between people? Why should I go with Gogo, or why should I go with Satcom Direct, or why should I go with Universal or AirLink or whomever it's going to be? So.
I'll tell you why you should go with us. We have we've invested a lot in the technical support of the system. So, and as part of Rockwell Collins as a wider organisation, we've got all of that kind of to play with. We also we've been connecting aircraft for now nearly 40 years, whether it was data links. So we look at the whole. I'd like to actually sort of raise the idea that we should be talking more about the connected aircraft and what else you can now do with it with the advent of this. Yes, the passengers being served, that's become a bit more of a hygiene factor now. Now what else can you do with the aircraft as we add more data points, and what comes on and off the aircraft that helps you to manage it better? So that's another part of it. But anyway, we have people around the world who are able to troubleshoot, help manage the aircraft systems. They understand it nose to tail.
But you won't reduce your price, is that right? No.
Sure.
Okay.
What do you want? How much do you want?
Well, there we go. Okay. So does anybody offer all-you-can-use pricing, or fixed sets amounts, or buy as you go, or big bulk purchases?
We have that on a couple of the VVIPs. It's an all-you-can-eat plan, basically unlimited data. It's $25,000 a month, but we do get customers buying that. Certain folks who are flying around in the BBJ and they want everything they can have and don't have to worry about it's a set cost. They plan for it for the whole year, and then they're done. So we do have unlimited plans, and it's like they're using a lot of data. So.
Yeah, I can add to that. So everybody, with a show of hands, I'm pretty sure a lot of people used Inmarsat before on airplanes, Swift broadband, Bill Shock, et cetera, et cetera. We're not cheap, we know that. It's also not cheap to put a system up into space, as everybody can contest. So a certain network has a certain value, and from a business point of view, that has a certain price that goes down from wholesale, Inmarsat, to the retailers, et cetera, et cetera. The value that actually is being added to those services, that is, in a lot of cases, especially in the corporate jet industry, that is what dictates the service. Price is of interest, largely to the director of maintenance or the flight departments, but the service needs to be adequate for what the actual mission requires. Having said that, Swift broadband, it's not too fast, really expensive. Global Express, the new system, KA system, that is, in essence, it is a flat fee which comes with a allowance. Now, we've got about 200 systems for business aviation online, a couple hundred for airlines. For business aviation, even though we have allowances in place, hardly anybody reaches those allowances. So that tells us two things. We are giving away too much spectrum, or people haven't really grown accustomed to what the new system can actually do, because everybody has inherently, don't use too much, don't stream, don't do anything. So the allowances for now are way too much, which is good, because that gets people confidence up. But the good thing is, when we have more people online and people will start using 4K TV, they'll literally go onto the airplane, put on BBC, Al Jazeera, Russia Today, and then whatever, Netflix. That's when we'll see actually allowance start ticking up. But by that time, we'll have more and more spectrum and capacity up in space, then we're going to probably up those allowances again. So it's going to be a bit of a bunny hop game. But for now, it's we're uncharted territory when it comes to all this speed and bandwidth up in the airplanes.
And the new systems are sort of moving to a more it's bandwidth consumption that you're looking at rather than how much data. The allowances are very generous. You'd have to be flying the aircraft quite an awful lot, streaming all the time to even start to run into them. But you could only do, the other thing is the speed of the connection. So you're buying the bandwidth speed, and you've got to start doing a little bit of maths of thinking, how many people are likely to be on board? So how many simultaneous devices are going to be in use doing what at any given time? And that's going to give you an answer roughly where you need to be thinking about for your service plan so that you can get a good service that meets your needs.
Okay, so for the operators in the room here, anybody who has Wi-Fi on airplanes, I know every charter operator's had a charter flight where they've booked it and someone used the Wi-Fi and a $12,000 bill comes down the road, but 3 weeks later. And we've seen this point of pain so many times. And every airplane I've ever been on that had Wi-Fi, it was disconnected and the circuit breaker pulled to avoid this scenario, which becomes completely pointless at that stage in the game. From a user experience point then, what is it that operators can actually do to prevent this happening? I mean, I'm going to give an example here. On Google AdWords, I can say I will spend no more than $100 a day on advertising clicks. Why is it that operators can't do this with Wi-Fi or with bandwidth to prevent that from happening?
Go ahead.
No, they can do that. I mean, there's systems out there where you can limit what you could do to the customer. I mean, I know your system, you guys just launched one. We're going to be launching one here shortly where you'll be able to manage how much data is being used and also track it and bill it and all that kind of stuff a lot easier going forward.
How soon will that come out?
Sometime mid to late this year.
Yeah, we've got real-time data monitoring. As soon as we get the data records from the satellite provider, that can be shown.
There was a caveat there, James. I mean, so how long does it take from data to go from you to the satellite
Literally,
provider?
you could be, it's happening all the time. It's a continuous feed. You can also, you can set alerts. So as you see usage increasing, and you can monitor it. Look at what's actually being used either straight after the flight, and that's what a lot of the operators do. They look at what's happening in use, whether they're even going to enable it. The other option is that we can take over the retailing of it. We can literally set up a portal, so we become a bit like when you're on the hotel Wi-Fi. You have to log on. We do a capture of the details of the person, and we can do a credit card transaction right there and then that allows them to purchase a certain amount of bandwidth or capability. Yeah.
So this is one that I find to be more interesting, and I'm going to pick on you here. And Jim, I'm particularly going to pick on you because you do both of these things here. But the other day I flew from London back to the States. I jumped in American Airlines. I put $19 on, and I got unlimited Wi-Fi for a 10-hour flight. And it was, again, not streaming movies, but it was good enough to do everything else. So but why is it an airliner I can get unlimited Wi-Fi for $19, but it's $8 a megabyte on a business jet?
Two things: economies of scale, and then the airlines tend to subsidize it. Like certain airlines, like if you go on Delta Airlines, you get free Wi-Fi, free texting, because their thought is, I want passengers who pay money for the seats, which is where I make all my money. I'd rather have that than pay, and that's one of the enticers get them on the airplane. The other thing is, an airline's got 700 airplanes with thousands of people logged on every day. So yeah, they're getting wholesale data prices. So they're not paying the same amount as a single jet with 2 or 3 operators on board. So they're using a lot of data every day, so they get special pricing. The other thing that goes on too is the pricing model that we have for the airlines is sometimes we do the portal and they charge directly to Gogo. So you swipe your credit card and Gogo's actually running it. Sometimes the airline's doing it. Each airline is separate, and they put up their own plan on how they want to do it. So the airline market's a totally different market than the corporate market. Our data rates, most of the airlines now are on either the air-to-ground network or the KU band. And the KU for us is off we're getting good rates on it because we buy so much KU data. Our data plans, when the KU comes out, you're looking at probably 50 cents a megabyte for our base plan, which is $5,000 for 10 gigabytes of data. That's what we came out with when we launched the product. So you're going to see data rates go down quite a bit in the next few months.
And I guess if fleet buying is a big deal, then it kind of begs the question. I mean, I'm sure the operators between them in the room probably represent 700 airplanes here. Why couldn't they just come together as a pool buy and buy in bulk as the airlines do?
They can. And we have fleet operators now on our air-to-ground network in the U.S., and they buy, they get different rates than a single user.
So I guess finally the other one I've heard or I think about is where in the world can I use it? I mean, are there black spots here? Are there not black spots here? I mean, what have you guys done? So, I mean, is it a pretty capable thing? And you've sent over some pretty good graphics here, which I'm going to pull up, but I need your help explaining them. And it's, oh no, see, there we go. Technophobe, here it is. Sorry, guys.
Sure.
So, Arno, I'm going to have you explain this to me because I'm a little out of
Yeah,
touch
no,
here, so.
this is basically a superimposed map of all the constellations that Inmarsat had at this moment. So, Inmarsat used the geosynchronous satellite constellation. So we believe that with 3 satellites, you can cover enough of the Earth for us that it makes business sense. You know, there's other companies that decide they want to cover the poles. We decided against that. So with the 3 satellites, I'm not quite sure if everybody can see this properly, but so we have, I'm going to focus on the I-5 satellites, the GX. So we have 3 satellites that are currently in orbit, giving full global coverage from an Inmarsat point of view. And for those that actually have used Inmarsat before, it's the usual recognizable coverage map. But it is physics. We're talking 36,000 kilometers, almost 22,000 miles up in space. Gives you a wide footprint, so small amount of satellites give you global coverage. But physics comes into play. There is, of course, you can't cover everything, and of course, this is a 2D map of a 3D world. So that means if you look in between North America, was that Canada? So you can see 2 satellites, and there's a big gap in the middle. There's nothing we can do about it. It's physics because it beams down. But if you look at the same coverage position, let's say over the North Atlantic track, there should have been a gap in the middle is there. And there's something we lovingly call the shark fin, because it's a very popular route for our aviation customers out there. So we knew we had an issue there because our global express footprint doesn't cover it. So we've leased capacity from Thor 7, from this Norwegian company that has the KA network as well. Same network as our GX satellite constellation to fill the gap. Here you go. So that's how we go about it. And then the interesting part is, and the satellites nowadays and the network itself, it's getting a lot more sophisticated than it was 10 years ago, 20 years ago. The KA coverage and the KA network, we've put a base layer in of 50 megabits per second per spot beam. And it goes too technical and I'll skip over it. But that we know perfectly well that is only a base layer. It's not going to be enough, it never will be enough, and we need to be adding more and more capacity. So while we are leasing capacity to plug in holes, let's say over the North Atlantic track, which we for physical reasons can't cover, we will lease capacity. We will probably keep doing that because we have an inkling where the most popular routes are going to be, but ultimately everybody here in the room, they will dictate where capacity is going to need it. So we will keep adding capacity by leasing it, shooting up new satellites, et cetera, to make sure that where there's a high demand, we will add more capacity. And then I heard you touch upon how it works from a handover point of view. There is, again, physics. If you are focusing on one single satellite, which it's up in space, and then you go from, let's say, one satellite over to the other, you will physically have to disconnect from that satellite and focus on the other one. But nowadays, with technology, especially when you're streaming a movie, you are buffering content to such a degree that you will continue watching the movie without actually knowing that you're hitting over 2 new satellites. So there is a certain element of physics that we can't overcome, but technology will overcome most of it. And if not, we'll just add more satellites in.
So, Jim, we have your coverage map up here. With blue and purple here, what does each mean on each one of these things?
So the blue is the current KU satellite network. So these are the satellites that have been up for a while. So KU's been around for many years. So you've probably seen it on other type of aircraft. Live TV streamed over it. Direct TV in the U.S. is streamed over KU satellites. So there's quite a few KU satellites already in orbit. At the same time, the next generation are going up. These are what we call high throughput satellites. So these satellites are going to be getting 200 megabits per second type speed. So what you see in blue is the current KU network, and what you see in purple is the future high speed. And some of those are already up. So this graphic's from actually early 2017. So there's already been a couple of satellites launched. They're already starting in the high throughput satellites up there. So by 2019, all those satellites to be up in the high throughputs there. And that's, what we've been working with on the airline side to cover all the airline routes for the most part. But if you look at business routes and the airline routes, there's like 99.6% coverage. So both of them are almost identical for most of those routes. So we got a very good footprint with the KU satellites right now.
And then just before we open up for questions, just one more question for you is the air-to-ground network is a great system in the States that is ubiquitous on pretty much most airplanes over there because it's very price effective. Why does that not work in Europe?
The big factor was the U.S. is one country, so there is one licensing authority, and we won the bid in that license, so that allowed us to do the air-to-ground network. In Europe, you got roughly, 37, 40 countries over here. Each country has its own frequency band. I know Lufthansa and Nokia are trying to do an air-to-ground network in Europe. There's been a lot of talk about it. I know they're running into some regulatory issues on the frequencies right now. So that's one of the big issues is we're lucky that it's one country. We actually moved into Canada too, actually recently. So we had coverage in Lower Canada, but once again, you're doing it with one country and one frequency band.
Are there any questions?
I can add to that one. Luckily, Inmarsat will have a European aviation network, which is akin to the air-to-ground network for Europe this year. So, just saying.
All right, well, Al's telling me we're done. We're done. So thank you very much, everybody. Appreciate it. So.